Hello, welcome to my YouTube channel. This is Mr. Civil once again. If you have not yet subscribed to my channel, please subscribe and don't forget to press the notification button to get all my latest videos. So in the previous tutorial, that was example 3, I taught you on how to calculate the top width and the base width when you are given the ratio of the slope of a retaining wall. So in today's tutorial, we shall find the maximum and the minimum stress at the base, but in this case there is a superimposed load on the retaining wall. So let's get started. The question says that a trapezoidal masonry retaining wall, 16 meters height, top width of 1.5 meters, and then the base width of 6 meters, has earth surface vertical and carries superimposed load of 8 kilonewtons per meter squared. The weight of the earth is 18 kilonewtons per meters cubed. The weight of masonry is 24 kilonewtons per meter cubed, and the angle of repose is equals to 30 degrees. Find the maximum and the minimum stress at the base considering 1 meter length of wall. So let us look at the solution. So we are given that the height of wall is 16 meters, the height of the earth, which is small h, is equals to 16 meters also. The top width, which is A, is equals to 1.5 meters. The base width, which is B, is equals to 6 meters. The superimposed load on the top is sort of W1, which is equals to 8 kilonewtons per meter squared, and the unit weight of earth 18 kilonewtons per meter squared. The weight of masonry is equals to 24 kilonewtons per meter cubed. So this is a simple sketch I have drawn. So you can see that it has a height of 16 meters. The top width, which is A, is 1.5 meters. And then the bottom width over here is 6 meters. And then this is the superimposed load. So this can be any load. Let's say it's a road passing from there or anything else. So this is our superimposed load, which is 8 kilonewtons per meter squared. And then here we have our resultant pressure. This is our resultant thrust. This is the resultant weight, and we have our center of gravity at this point. So first of all, we shall calculate the horizontal thrust due to the superimposed load acting on the vertical face. So this is the formula. We will denote it as P1, which is equals to this W1 is the weight of the imposed load multiplied by the height of the earth, and then again we multiply it by 1 over the sine of the angle of repose divided by 1 plus the sine of the angle of repose. So here I have just replaced the values. So it's 8 times 16 times 1 minus the sine 30 all over 1 plus sine 30. So your answer, you'll get it as 42.66 kilonewtons. So this will act at the center. So it acts at the height 16 all over 2, which is equals to 8 meters from the base. Then now we shall calculate the horizontal thrust due to the earth acting on the vertical face. So this we shall use the formula P2. This is the second horizontal thrust, is equals to W2. This is the weight of the earth multiplied by the height of the earth squared all over 2 multiplied by 1 all over the sine of the angle of repose all over 1 plus sine of the angle of repose. So I've replaced my values here. 18 multiplied by 16 squared all over 2 multiplied by 1 minus sine 30 degrees all over 1 plus sine 30. So when you calculate this, you'll get the horizontal thrust due to the earth acting on the vertical face to be 768 kilonewtons. Then we shall calculate the weight of the retaining wall. So weight of the retaining wall is equals to the unit weight of the masonry wall multiplied by A plus B all over 2 multiplied by the height of the retaining wall multiplied by 1. We are using 1 because we are considering a 1 meter length. And then I've replaced my values. So 24, this is the unit weight of masonry wall, and these all are in kilonewtons, multiplied by 1.5, this is our top width, plus 6, which is our base width, divided by 2 multiplied by 16, which is our height, multiplied by 1. This one will give your answer as 1440 kilonewtons. And then let x be the distance of the center of gravity from wall to the vertical face. So it's over here. It's the distance from A. This is our B. So it's the distance from A to the center of gravity, which is x. So our x will be equal to a squared plus ab plus b squared all over 3 into a plus b. So replacing the values of a and b, that is 1.5 squared plus 1.5 multiplied by 6 plus 6 squared all over 3 into 1.5 plus 6. So when you calculate this, you'll get your answer as 2.1 meters. And then now we shall let x1 to be the horizontal distance between center of gravity line of the wall and point E, where the resultant thrust intersects the base AB. So this is the distance from the center of gravity to the point where the resultant cuts at E. So it cuts over here, we have labeled it as E. So from here to here, our distance is x1. And then here we know that our P will be equal to P1 plus P2. So this is the total horizontal thrust, P1 due to the superimposed load, and P2 due to the earth. And then when you take moments about E, it's over here. When we take moments about E, W, this is the weight of the masonry wall, multiplied by x1 will be equal to the moment of P1 about E plus the moment of P2 about E. So this is when we take, this is our weight. When we multiply, when we take moment about E, our weight, and then multiplied by x1 will be equal to the moment of P1, which we calculated about E, and the moment of P2. So when we replace our values, our P1 multiplied by 8, so Wx1 will be equal to P1 multiplied by 8 plus P2 multiplied by 5.34. And then we know that we were given we calculated the weight of the masonry wall and got it as 1440. So I have just replaced my values. 1440 multiplied by x1 is equals to 42.46 multiplied by 8 plus 768 multiplied by 5.34. So P1 and P2 we calculated previously, and then when you want to find the value of x1 will be equal to 42.66 multiplied by 8 plus 786 multiplied by 5.34 divided by 1440. So you'll get your answer x1 as 3.08 meters. So our horizontal distance AE will be equal to A plus x1. So we got our x and our x1. We got it as 2.1 and 3.08. So when you add, you get your answer as 5.18 meters. So eccentricity E is equals to AE minus B all over 2. So this we have seen in the previous examples. And then our AE, which is the horizontal distance, is 5.18 minus the base, which is 6 all over 2. So when you calculate this, you'll get your answer as 2.18 meters. Now we shall calculate the maximum intensity of stress at hill A at this point. So our maximum intensity will be equal to the weight of the masonry wall divided by the base into 1 plus 6 times of eccentricity divided by the base, which is equals to 1440 all over 6 into 1 plus 6 multiplied by 2.18 all over 6. And then when you calculate this, you'll get your value as 763.2 kilonewtons per meter squared. Because it is positive, it's a compressive force. And then the maximum intensity of stress at toe B. So we have our toe B at this point. So we have to find the minimum intensity there. So our minimum intensity will be equal to the weight of the masonry wall all over the base width multiplied by 1 minus 6 times of eccentricity divided by the base width. So I've just replaced my values over here. So F minimum will be equal to 1440 all over 6 into 1 minus 6 times 2.18 all over 6. Then when you calculate this, you'll get your value as negative 283.2 kilonewtons per meter squared. So since our value is negative, the force that will be acting there will be a tensile force. So that was all about example 4.